So much of our work was done by this group, the team members, the volunteers who helped out 6 months ago, and we presented much of, we were largely complete with our edits 6 months ago. So this is just an update. And what I'll do is I'll review the structure of the of what we've produced, and then I'll have a few slides on some issues that remain. So planetary defense is goal 2, and it's the familiar set of objectives. I've shortened the wordage here. 2.1, identify and track PHOs here. Characterize the properties is objective 2. This is the broad outline here. Objective 3 is do the modeling to assess the risk to Earth from impacts. So this is the impact modeling and what's involved and the implications of impacts on the population. Number 2.4 is mitigation, and develop what the approaches would be, and like DART, we have demonstrations of them to address the wide range of potential impact threats. And 2.5 is the coordination issue, not just within agencies within the U.S., but also internationally, to enable emergency response and recovery. So that's the broad outline of the planetary defense goals. And it is essentially the same as they were for the 2016 goals. So these are largely the same, and we've updated and revised the text as appropriate. Just to go one step deeper then, on each of these, number 1 is identify and track. So it's surveying, and under 1 is surveying capabilities. We've got to find them. That's the first priority. The second one is to identify imminent impactors. So we have a section on that. And then number 2, characterize the properties. This is, as we were saying, this has the largest intersection with other sections of the goals document. Determine physical properties of the NEO population, and determine the chemical and compositional properties, which means structure, so that we can infer mass when possible, if we can't measure it directly, and infer how the NEO would respond to mitigation attempts. So we have a section on that. Number 3 is the modeling of impact effects, as I spoke before. Better understand the effects and the damage implication of on the ground. There's been a lot of work done in that area, and that section has been heavily revised. And the second one under 3 is exercises. Develop, maintain, excuse me, that's not the exercises, that's later. Develop, maintain, and exercise the impact risk assessment tools. So what are the tools we have available to analyze impact threats rapidly? And continuing, the fourth one was the mitigation attempts. So we, under 4, ensure potential threats are identified and addressed early. That's the computing impact probability and that sort of thing. Develop and demonstrate planetary defense approaches and missions. So that so DART, for example, is addressing that. But we'll keep this goal in there. That's important to do. And there are other deflection approaches which need to be also demonstrated, or at least heavily analyzed. And develop a rapid response capability for characterization and mitigation. And so rapid response, there's been more work done in rapid response characterization. That's something that we have revised a section on that. So that's something that you should review and comment on. And the last section in planetary defense is coordination. So that's heavily revised from 2016 for the last go round anyway, because the PDCO now exists. So basically we're saying support the PDCO, make sure it continues to thrive. Interagency cooperation, there's much work that it's done there, and I want to point out the fact that we have, since the last SBAG, we have the National Near-Earth Object Preparedness Strategy and Action Plan, which is a U.S. government document that summarizes the interagency efforts to coordinate, establish protocols, communicate, and then actually have plans which address many of the SBAG goals. So there's a lot of commonality between the SBAG goals as we've written and the goals that are mentioned in this plan. This document is available on the PDCO website. I'm not sure we have it on our CNEO's site, but it's, and I'll have a slide to talk a little bit more about that. And the last point here is the international cooperation. So we revised the text a little bit on that because we have the IWAN that is well established and up and running. That's the International Asteroid Warning Network. And we have the same page, international group for space mission planning for response to the NEO threat. So that's addressed in that section. So I invite the community to look at the current draft. Yes, questions?
I'm wondering if you could comment on who the other agencies are that you're coordinating with.
Okay, so you're talking about the new plan. I have a slide on that. So I may answer that question on the next slide. Any other questions? So what I've done here is just review kind of the outline of the goals, and I invite you'll all get a chance to review them and comment on them. Of course, we've had this group which is mulled over and heavily revised the goal document. So I'll continue now to what's new since this, because these are basically what I presented last SBAG, and you'll have a chance to see what we did. But what's new has not been incorporated in the current draft. So my first point is that the draft is largely completed, but what's new is this document that I've written, that there it is, there's the name of it, which was issued in June 2018. And you were asking the agencies that were involved in this. So the agencies would be Homeland Security, which I think incorporates FEMA, and NASA, of course, is the lead agency. There's NNSA, there's the nuclear labs, and I'm probably forgetting some, and NOAA for some of the simulations of impact effects over the ocean. So there's a number of agencies that are involved in this. So I encourage you to just take a look. Did that answer basically your question? So what I've listed here under that bullet point are the 5 goals that were identified for this action plan. And what the plan is simply a plan of what should be done, and there are now working groups formed to pursue what should be done on each of these goals. So to actually form the plan, that's still underway. And you'll see the commonality here. The number 1, enhance NEO detection, tracking, and characterization. Well, that's very similar to what we had. Improve NEO modeling, prediction, information integration. That's involved in understanding the physical and the orbital properties of NEOs. Develop technologies for NEO deflection and disruption. So this is the rapid response, reconnaissance, and the deflection missions. So what are the technologies then that should be developed so that we're ready on short notice to use? So that's in their plan. Increase international cooperation. That's very similar to the goal we had. But you can imagine that the international issues that could arise with coordinating amongst various space agencies are significant. And so this is going down into much greater detail on that, how governments interact. And one second, and the last under this plan is the strengthen and routinely exercise NEO impact emergency procedures and action protocols. So that's where we get to have our hypothetical impact exercises, and I get to be a threat master and introduce all kinds of curveballs. And we'll have one of those at the PDC coming up. This is about the 7th or 8th one that we've had. Yes?
Comment from online with the federal agencies cooperating in the action plan are the DHS, FEMA, DOD, DOC, FAA, NSF, and many others.
Oh my goodness, I'm not going to remember all that.
Yeah.
So I got some of them, but
Yeah.
FAA, and
quite a few.
Quite a few are listed.
Look online to the chat window.
Look online for the large list, or just go to the document. Okay, it's, as I say, on the PDCO website.
DOD includes a fairly broad.
DOD does, yes.
Yeah.
They are, as far as I understand, the involvement there is through the NNSA, the nuclear folks. I think that's their main involvement. Any other questions on the action plan? So we haven't incorporated this into our goal. So the intent then would be to modify our text so that we at least refer to to this document and kind of allude to the fact that many of these topics are discussed at a higher level than at NASA. This is interagency. Okay, so we will modify our goals text to the section to reflect that. Okay, any other questions on this stuff?
Oh, here's another one from Victoria Andrews.
Yeah.
So the Secretary of Defense, Space Command, Defense Threat Reduction Agency, and the Air Force are among others.
Victoria, who is in charge of this, has itemized the number of agencies, so there's quite a list. So it is a broad interagency effort. I'll leave it at that. Okay, and my second bullet point here of what's yet to be included, or what's new since the last SBAG, are the Planetary Defense Conference hypothetical impact scenarios. And for the one coming up, I hope many of you can be there, there is the asteroid impact scenario, which we will discuss extensively at the conference, and we'll go through the various stages of that in great detail. And we hope to have decision makers at the conference to give their opinions on what the decisions would be at each level. We hope to have 5 time steps in that asteroid impact scenario. The warning time in this case is 8 years, which is a little aggressive, actually, from my point of view, but many people think, we should be able to deflect something in a lot less time than that. It's not easy. And by the way, the orbital inclination of this particular impact threat is 16 degrees, so it's a little bit harder for the mission designers to do. And that's not atypical for impactors. Remember, this is not like missions to asteroids where you get to select your target. The target selects you in this case. So that's a difficult case. And a second scenario, the bottom point here, is a long period comet scenario that I put together for the PDC. Now that will not be discussed explicitly or presented explicitly by us at in impact scenario exercises, but it's online. Both of these are online. In fact, I think I can give the URL on the next slide. And a long period comet scenario in this case is a warning time of 22 months. So that the long period comet hazard was something that we had a lot of discussion with in our group, and that's on the next slide, my last slide. And just to remind you, that's period comets with periods greater than 200 years. So you haven't seen them in the past. This is the first apparition, which means they come in totally unknown. The hazard we felt in the SDT report is still on the order of 1% of the asteroid hazard, but there is a proposal to further analyze the statistical hazard of the long period comets, and so I think we'll adjust our goals to include a goal to that effect. And Gerbs-Bauer has drafted some text. Now, we even talked about this at the last SBAG. I'm not sure whether the long period comet threat is high enough to put a lot of effort into. Now, that's a very debatable point here, but it may warrant a goal to at least study the statistical threat of the population of long period comets on the Earth, and there's more work to be done in that area. So that's something we'll add to our goals. Now, I want to go into, since I thought this might be a point of contention, I was going to go into some of the details. The nuclei of long period comets are big. 500 meters is kind of a minimal size, is my understanding, and many of them are much larger. So that makes it a very difficult kind of threat to mitigate. They're typically not discovered until they become active, which is kind of somewhere in the region of 6 to 10 AU, unless they're really big or they're different composition. They may be discovered a little farther out. But the point is, they're not discovered until fairly late. They're coming in at a high velocity. For the PDC comet impact scenario, I set it at 8 AU for a roughly 1 kilometer comet, which is similar to Hyakutake in size. And that means the warning time is less than 2 years for even a potential impact. You know, the smallest probability of impact. You know, we know it may come near the Earth 2 years out, which is not much time. The non-gravitational effects vary widely among the long period comets from one to another. They cannot be quantified until the comet gets in close. So basically, you can't tell. You can't make accurate predictions about what it's going to be like at 1 AU until very late. So warning time for certain impact is less than a few months. Now these things are coming in at high velocity, and for the comet scenario, I put it at a retrograde inclination, the same inclination as comet sighting spring that went by Mars. So it's not atypical. So the bottom line is comets are extraordinarily difficult to mitigate, and therefore we did not address that much in the document, in the goals document, and the SDT similarly did not really focus on this. Now, some of my team will point out that the risk is the product of probability times consequence, and the consequences are could be enormous. Hale-Bopp was what, 40 kilometers, and it went very close to the Earth's orbit, just around the other side. So you can multiply that out, but my point is that that's a moot point because mitigation is extremely difficult. And in the comet scenario, we've set it up into the NEO deflection app, and we can actually try out deflecting one of these objects, and you can see how difficult it is. I don't want to say much more about long period comets, but I know that topic will come up. That's all I have. Any questions? Dan.
It's possible that bilobate objects would be maybe much more common in the long period comet population. Does that pose a serious problem in deflection?
Dan asks whether bilobate nuclei would add an additional complication on top of this. And of course, I would first address it in the asteroid population, and I think we had, that's one a possibility for an asteroid scenario. I agree that the difficulty of mitigating a long period comet is simply getting there far enough ahead of time to have any delta V have enough time to make it miss the Earth, basically. And most of these long period comets, if you want to get it to, of course, they impact as a node. They spend most of their time well out of the plane of the ecliptic, so they're difficult to get to. So that's the bottom line. And you can, and if you'd like to look into this more deeply, you could look at the comet scenario for the PDC, and we see that we could only hit it maybe a week or so before it passes the node. That's not enough time. Any other questions from? Oh, yeah.
Just a quick comment from GERBS online, from NEOI's long period comments are how to develop size 2 kilometers.
Yeah, so GERBS online says, typical size is 1 kilometer.
Or even 2 kilometers.
Or even 2 kilometers. So I used 1 kilometer for these comet scenario. Any other questions? So I encourage the community to review the planetary defense draft, and we will continue to add to it.
All right, thank you.
Thank you.
And coming up next, human exploration, Dan Adamo.